Hello everyone and welcome into yet another live stream. Now, I'm tired. Give me a second. So, good news. When it comes to the project I'm working on, the site, it will be here sooner than expected. I've made some progress on that, and right now I can tell you it should be before or around probably 6th of July. That's probably when the project should be up. Normally I should wait more, but truth is I don't want to. I don't want to wait more because waiting more would require me to not make any, more videos for 25 days, which is already a lot. Instead I'll try to do 20. It's really hard for me to not make videos like that, not post them. It's very unnatural, if I may. Add streams. I should probably add MKT chat streams. I should probably make subcategories. There's like instead of pinging people for normal streams and stuff, I should ping them based on science streams or whatever. Because today this is a science and technology stream. There we go. And this is a project. It's a battery. Yes, this is the battery charger design that I came up with. It should be decent. It should be very much decent. It's actually very simple, this entire thing. It's unbelievably simple. These, though, should be connected to this thing. So let me just connect them really quickly. Actually, probably like this would be faster. There we go. Yeah, so this is the entire project. So here's the thing. We have three different wires going. This is Raspberry Pi. And we have three different wires going to the Raspberry Pi used to measure voltage. We have 9 different digital buses. It's called a bus. This is a bus. 9 different buses which go to it that control different flows. Over here, they would control. Over here, they would control the transistors. That would determine, because we have only 3 analog inputs into the Raspberry, and because of that, I had to do this thing, which would be actually quite pricey for me, because every single transistor, when it comes to, I was looking into the parts basically that I would like to get for it, and let me just find the right thing. I'm make a fool of myself. Let me just also do this. I'm in London. That's great. Festive. Now, open link, and open link. So here are all the parts that I would like to use for it. First of all, when it comes to transistors, and rather not cheap one, right? It's kind of expensive. 79 cents. In larger quantities, obviously cheaper. So instead of that, I'll probably buy 100 of them for $49. It's expensive, yes. But I'll just buy 100 because we need 8 per circuit. 1, 2, 3, 4, 5, 6, 7, 8 per circuit. So yeah, I'll buy 100. That will be enough to make 12, I think. 12 charges, that's good. $49. Pricey. When it comes to resistors, this is just some resistor, 1K, but this is just as an example, a 1/4 of a watt. Oh, fudge sticks. Okay, so for resistors, we'll have to find something else. Resistors. Yeah, mind the GTA. What I need is, what kind of resistors? Well, we'll need 2 kinds. We'll need a couple. All of these should be the same. They will, because basically we'll have a constant input voltage, and with these resistors we'll determine the amperage. So I feel like 100 ohms would be decent there. But this is an average price for resistor, 55. As you can see, they all are the same practically. Yeah, different amount of ohms, different watts. Actually, wattage is this watt fudge. Fudge. Output current 12. Well, yeah. Wait, it's package. I'm looking for resistors. Resistors. Yeah, resistors. Bulk resistors. Yes, this one. Normally stock family resistance, tolerance, power rating. Okay. The thing is, we'll need to send a lot of watts through them, which will be, length doesn't matter because that will be for the PCB. But oh boy, this will be quite a pickle. In Stockholm, no, that doesn't matter. We're buying in low quantities for now. So, resistance. First of all, what kind of resistance over here? Well, over here, I would like to diverge 1% of the voltage into the Raspberry Pi to measure it, and 99 over here, which means we need 1 to this. So 10 and 1000. These are expensive, but that's the right idea, at least. Power resistor. Well, there's a power resistor. Does sound nice because that would mean that it shouldn't power rating 10 watts. We are getting 20 watts on input. To be fair, we would need to regulate that later on. Yeah, we will need less. To be certain, we will need less. So here's the thing: we are getting, because from the chargers we should get a stable supply of voltage, not wattage, voltage, and because of that we should regulate the amperage with resistance, and thus, yeah, it is expensive, but I'm looking for good, not for cheap. I want this to be good. But in bulk, yeah, we won't be buying in bulk. If we were buying in bulk, and this price is lovely, but I ain't got the capital to buy them in bulk. Now, power rating on the resistor, we should look up exactly what that means. We shouldn't really, because in theory it's obvious, but if it's not, then I would like to know. Resistor. Yep. Bicycles. Verify. Watts and is usually 1/8 of a watt and 1 watt. Well, yeah, we have 10. Power dissipating. Wait. What is... Maybe we don't want that. This power dissipation can safely dissipate. Dissipate in the context dissipate, or dissipate in some very rough, electricity. I don't know if my chat is working, by the way. I should probably check. For some reason, YouTube Studio just dies sometimes. And let me refresh. There does not appear to be any messages in chat. Okay, I think it's working. Hard to guess when it's working, when it's not. Alright. So, power rating definition. Power rating is dissipate. Is it normal definition of dissipate? Because normal definition of dissipate would be good actually for us. Define dissipate, because then we could buy the cheaper ones. Waste or fritter away. Yes. So dissipate means get rid of, right? How many watts it's getting rid of. So we do not actually need power resistors, because they basically lose wattage. They lose a lot of power. We don't want that. What we do want is low power ratings. There's only one that has 25 and it's 220 ohms. I would really like to get some different ohms. Power rating 5 watts, that's a lot already, but 0.25. Alright, so let's get 10 and 1000. How about that? Ohms. resistance. Where's resistance? Here it is. 10. Oh, you can get 1. 1 would be tempting, but I feel like, okay, no wait. There's 5 kilo ohms. There is no 1000. Well, we can get 505. Not what I meant. I wanted both. Oh boy, this website is a bit. Power rating are correct. Okay, power rating is correct. Now resistance. There's only one type of each. All right, let's select this one because this one will give us 2, and because I will be able to select also 5 and 500, and there we go. And now we have these two. 39, which is not little, and 35, which is also not little. But fortunately, we would need only. How many resistance? Which one's which? This one's 500. We would need only 2 of those and 1 of this. Basically, in our circuit, we will have 500, 500. This one is just a safety measure against short circuits. Because there could be a case, it's unlikely, and probably wouldn't happen, but I just want to get additional thing against short circuits. Just in case. Alright, is this good? Now the LEDs. Yeah, Legends of Tomorrow, like that. LEDs over here, they will be glowing if it's charging. 30 volt amperes, so 30 watts. Is that what it is? Current, peak wavelength, luminous intensity, diffused color, yeah, height. Typical forward current. I have to also check LED, how much power is lost equation, if I may. So based on you multiply LED forward voltage, forward current. Okay, so forward current. So forward means how much is lost. Where's the value of LED? No. Not quite what I'm looking for. Dissipated by LED. Power dissipated by forward voltage times forward current. That's okay, so that's it. Good. So then it's 30 milliamperes. That's good. That's very good. That's very good. 2.2 times 0.03. 03? No, 0.3. No, 0.03. Yes, 0.03. There we go. 0.66 watt. That's fine. Very good LED. Great. Now, get this. What else is there? The capacitor on the beginning. Capacitor which I am using to stabilize the flow of everything and make it handy dandy, cool and whatnot. And those are all the components except for one. If you have a good eye and you are really paying way more attention to the stream than you should, then you will also see the potentiometer over here, the digital one. Normal one would be easy. It would be just an easy part to buy. The problem is we're not buying a normal one because all of these parts are correct, but we're missing one. You know what the problem is with this one? Digital potentiometer. It's expensive. It's fucking expensive. This one is $2, which is, to be fair, it's not a lot for a part like this. The issue is we will have to send. That's actually kind of good enough. That's also decent. All right. We'll have to send a lot of power through it. I suppose the cheaper one, right? In this case, because there's no difference between them. number of taps. Digital potentiometer, number of taps, if I may. It's powers of 8, which leads me to, there's like precision. Oh. Yes, it was precision. Well, we don't need precision actually, so we can buy the cheaper one. We don't need that much of precision, because we'll just always choose to go for the safer option when it comes to any problems. Alright, cool. So we have everything, which means that pair 1, when it comes to only electrical components, right? It would cost me a lot of money. Okay, so this. It has 10,000 ohms of resistance. The basic idea is we'll use it as a voltage divider over here. Actually, we probably don't need this one because this will always be 10k. But basically we'll use it as a voltage divider to determine how many volts should go over here and how many should go away. And we'll use that because, well, we'll need to regulate the voltage, and at the same time, to regulate the current, I should do a current divider actually. Isn't this a current divider though? It is a current divider too, yeah. So it can work as a voltage divider or current divider, but considering that we have a source of voltage, it will be a current divider, which be voltage divider, I mean. So that means we'll have to somehow be really careful when it comes to the current. So we'll have to monitor batteries constantly. As you can see, these batteries will have also output over here, which I will have to also test if we need to. We shouldn't need to connect them either over there. But this right here, that should be enough. Also, we'll need to diverge a portion of this, obviously, as power. So this would be then power, and this over here, like so. I feel like this way more. Great. There we go. We'll need ground and power for the Raspberry, and there we go. That's the entire circuit actually. Simple, very simple. Hopefully simple. I actually don't know if it will be simple. It probably won't be simple. No, very sorry about that. But with this, we could build 10 prototypes and sell 10 prototypes. Because I do not have the money required to build the actual thing. So right now what we should do is we should open PCB editor. And how does this work? Why is this yellow? This is blue. Huh, interesting. Okay, so layers, objects. Listen, I downloaded this thing. Well, actually, I think I did it yesterday. There we go. Great, sick, festive. Delete. I got it. Okay, now I would really like the size of that to be appropriate. So what would be the size of our thing? In order to check that, we will need check something else, which will be Raspberry Pi size. Raspberry Pi Pico W specifics And for that, we'll open images in new over here, and this oh, it's inches. Oh, yuck, yuck. I think it's in inches. Is it? Wait. Ah, those are not inches. 21. That's insane for inches. Are these millimeters? Because if they are millimeters, it's a lovely day to me. I do not really have any sort of measuring thing anywhere, which is weird. I don't have a single thing which can measure length, which is fun. I just hope these are millimeters. These should be millimeters. Alright, so what would be the size of our board then? Well, it should be small. All we need to do is fit this over there. And this can be organized better. Okay, these batteries will be connected with a cable to the thing. They won't be reconnected. They'll be connected to the cable. So cables will be going away from the board for that. So I'll have to buy some wires. That shouldn't be a problem. But for this, well, digital potentiometer. Yeah, I should give them some decent space, I suppose. Size, grid. Oh, it's just a grid. Okay, doesn't matter. Well, as many as possible, preferably. But I would also like to change the size of this thing. Polar, you can use polar coordinates for this. Wouldn't that be a bit... No. Okay, so, step by step. Oh, this will be difficult. What we will need first is a rectangle that will represent our Raspberry Pi. I will need to have to take a look at this, because to double check everything. 21 millimeters. So like, oh, let's start over here. So for now it's only the size. This, we start at 26, 47, right? Length would be, I feel like I could change the size of that. 47, and length would be 48. So we start at 128 plus 48, that gives us 68 plus 8, that gives us 76. 76, 47. That was great. Festive. Oh, it's much better. 21 millimeters, if I may. $21.51. Raspberry Pi Pico, great. Now we have this Raspberry Pi Pico right here. We have it. This will be the place for it, right? Can we change the size of this entire thing? What's this? Unfilled zone. Vias. Yes, we'll need viases. Ah, Lord, this is this is difficult. Copy image. Can I just paste it over here? Yeah, I didn't think that would be possible to save the image as Pico W dimensions. Yes, reasonable. Pico W dimensions. I love how interactive this. I mean, that intuitive it is. If only there was a way to make this transparent. That would be great. Properties. Image. Can I like put the rectangle on top? Because otherwise I will be playing much the size for an hour. The size does not seem to be matching, by the way. Am I wrong here? I might be wrong. Please tell me I am wrong. This is just me being silly. No, the size is not matching yet. The shape. I need the shape to match. A bit bigger. Why is the size different? May I ask, why is the size different? Length of the entire thing should be 51. It is not. It's this. Oh, that's not. It does not seem right. Whoops. Damn it. Measure the distance between 2 points, right? There is something like that. Yeah. This point to this. That's 50. No, I mean 48. Which is, oh yeah, 40 is appropriate. Oh, 51, maybe 51 is from the, port. That actually would make sense. All right. Great. Yeah, I would like to leave that measurement. So now what we will need is the pins. Here we can see the pins. And we care about 3 of them mostly. And then the rest are digital. So we care about 3 ADC pins that we have over here. And then 8 digital, 8 or 9 digital. Actually, that's a good question. Then we care about 9 digital and power supply. All right, so power up Raspberry Pi Pico W with pins. Which one and how much?
Power to the Pico. The guide to everything you need.
I don't want really everything you need to know. I want good enough knowledge. Oh, cookies. All right. 1.8 and 5.5. Yes, most wide. I like it. Okay, so main Pi does the program. Okay. USB power supply or super battery pack and connectors, but I would like to with pins, if I may. Can I pin up power pins? Yes. Pin out? Yes. Pin numbering, ground, power pins. Input voltage, typically 5. Used to power system. Okay, so 39, that's the one we want to power. $39 to power and pin 3 to ground. Sick, slick, great. So now, terrifying. Now we can use this image to see that on the right we have VSys and ground right next to it. So on the right over here we can take this and we have VBus, VSys, which is the one we care about, and ground next to it. Those are our 2 starting ones. We have ground and the system. Sick. Now, when it comes to our analog stuff, so we have 3v3, 3v3 out, ADC vref, ADC 2, ground, and these two. I think. Great. Now, oh boy. So now this, right? So those are our three analog. Now digital. Digital will go from this side. We'll have 0, 1, 2, 3, 4, 5, 6, 7, 8. There we go. Those are all the ones, all we need. I really have to control the F now because this would be, this is terrifying. So these are Raspberry Pi stuff. Now, we'll need a power supply, which let's just put it over here, I suppose. This is actually very massive. Can I change the size of this thing? I mean, if we can move these entire things as segments, so we shouldn't worry much about that. For now, let's just do a general overview. Then I'll ask Tevta to please fix it because I will. This will be messed up. Is chat working, by the way? And why wait? No. Okay. Input. Power over here. Let me just get my phone because for some reason YouTube is not really showing the chat sometimes when you're in studio mode, and only is showing once you are looking through the normal stuff. Okay, great. So we'll have the input power from over here. Now, from the input power, we will need a couple of things now. So now it's time to consult our schematic here. We'll have two resistors turned into voltage divider and a capacitor, which means we will need to do something that looks like this for the capacitor. Connect them with a wire. Is that a good connection? It looks off very much. Yeah, now it looks fine. Over here we'll have a capacitor. How many millimeters? I feel like I would prefer... what's this? I would prefer 4 millimeters, 5 for this. This actually, I don't have to be that precise because the size of the capacitor won't really matter here. The capacitor has some pins, right? And I can just... Well, I have to solder these pins, so this won't really matter. But we get 6 millimeters, which is... Yeah, it's decent. That is very much decent. So the capacitor. Now, next, after the capacitor, connect over here, we will need what? Well, we will obviously need a resistor. Once again, that's pins, so size won't matter that much. And yeah, sick. Over here, this is actually a bit of a bigger issue right now because this should be a voltage divider, right? Yeah, a voltage divider which diverts 1% of the voltage into the Raspberry for measurements into these pins. So I can really see an issue. This power thing is awkward. It's awkward. Oh, I did not mean to make a rectangle like that. Oh no, this is not what I meant. Oh, fudge sticks. Well, this awkward. If I may select this rectangle. There we go. Great. Now, this would have to go Can we go on the inside actually? Because I feel like shouldn't be any problems. Hopefully, let me take a look at the Raspberry Pi Pico. This is. I don't think there should be any problems. There might be only a couple. Yeah, it'd be fine. We just have to navigate over here right through the middle of this. Yeah, it'll be fine. Up to this point. There we go. And then this is a voltage divider, so just do the next thing. Let's delete this. Also delete this. And this move is with M. That's, I should remember that. Why is this one different? I don't like that. Why is this different? Why is this different? That's terrifying. Why would you be different? I don't know. Well, let's just hope this will be fine. PCBs. Actually, I do believe I checked that before, but let's do it one again. PCBs, maximum current and voltage. Not quite what I'm looking for. Up to 30 amperes per board. Maximum voltage is 8, yeah, but that's good. Printed circuit board, yep, these are standards if I understand correctly, but what do standards tell me about? You have to get twice the current out of the same box as before. Okay, so I suppose 4 is good, right? 4 should be fine. Yeah, should be fine. Should be fine. Should be fine is always the right answer. Now, capacitor, resistor, which means it's time for the next thing over here. Freestanding vias, that is what I think, right? It is. Yes, Hall. Element that crosses 2 or more adjacent layers. Hole is covered internally with copper. The electronic board may require vias that cross all the layers. No. Okay, so vias is used as a whole, but what I need is something to connect to the circuit. So can I also use vias like this? That's a very interesting, huh? So maybe I shouldn't use vias for that. I'm an idiot. How to add resistors designing a PCB. No, I'm Not what I'm looking for. I'm more of a...
as an, so after that you can to what is you can see
So
6.25.
rectangle. So a rectangle. That's what we are. That's what we want to add. That's what rectangles are for. Okay, cool. So we can check the dimensions of our resistor. Alright, this one. Which dimensions are? Length, depth, height. Well, length and depth, I assume, is what we are looking for. 22 millimeters length, depth 10 millimeters. Alright. So length is 22 millimeters. Okay, that's with the pins, isn't it? I refuse to believe it's... I refuse to believe it's that... Okay, actually, it's quite expensive. Might be that large. But that large? 22 millimeters? That's insane. Through hole. Oh, I can... You know what? They say through hole, so I will do it through hole. Yeah, that's what they say, that's what I'll do. So over here we have two resistors. Grand. Now what? Well, now we carry on the circuit. Over here we'll need a potentiometer, which will be the most annoying part out of this entire thing. Why? Well, it will be the most annoying part because of how many pins it has. And then we need to control them. Over here we'll actually might need more digital pins. Let's check this potentiometer data sheet. It just would be annoying. I have to get through this entire thing. You know what? I feel like I'll leave this for the next live stream. I have done a lot for the project today and I am tired. So, for now, that'll be it. Thank you everyone so much for watching and have a great day. Bye.